So thanks everybody for coming. We're going to have a talk today from the folks from IntelliJ, from JetBrains. We've got two topics they want to talk about. The first one is a new product called Team Server, and that's going to be given by Dmitry. And then after Dmitry's finished, Mike's going to give us a talk on the new features we can expect in IntelliJ IDEA. This has been filmed and it'll be put on the intranet. So if you have any confidential questions, if you could wait until the filming has been completed. Okay, so thank you. So first of all, it's Dmitry.
So, good afternoon, ladies and gentlemen. My name is Dmitry Jemerov, and I work in the St. Petersburg office of JetBrains. I'm a software developer in the team that develops the IntelliJ IDEA and the Team Server products. So what I'm going to tell about today is our new product called JetBrains Team Server. Well, in fact, Team Server is not the final name, it's just a preliminary name, and Albus is another code name, so we are in love of having many names for our products. Well, never mind. So the product is currently in development. It's planned to be released in this summer. So this presentation is also one of the chances to give us feedback on what should we include in the final release of the product. So let's get started. So this is an overview of my talk. So first of all, I'll talk a bit about where the product came from, why have we started working on it, and then I'll cover the main feature areas of the product. So the areas are, first of all, it's continuous integration support. So of course there are many existing solutions for continuous integration, but it turns out that there are some things that we can do a bit better, a bit smarter, and the end result is the same, is improving the productivity of the team. Then I'll talk about the server-side code analysis for Java code that we can do in IntelliJ IDEA and Team Server. It turns out that moving the code analysis to the server can give quite a lot of new possibilities and to extend what we can do with the code. And finally, I'll talk just a little bit about the collaboration features that are also provided as part of the Team Server solution. The collaboration support is mostly lives inside the IDE itself. So I just talk a little bit about that. And finally, just a few words about extending the Team Server to specific build environments, like the one, I guess, as far as I know, that the build environment that exists in Google is quite different from many other environments. So if Google decides to introduce that, it will need some customization. And of course, it's all possible with our product. So first of all, I guess many of you know about our flagship product, the main product of our company, the IntelliJ IDEA. And it started its life as simply as a Java IDE for individual developers. But of course, real work that people have to do in a project, it involves much more than simply typing Java code. So initially we extended our support to other languages. So we support HTML, CSS, JavaScript. Well, in the second part of the talk, Mike is going to tell you much more about that part. And what I'm going to tell is the new dimension in which our support extended the support for team productivity. And the goal that we want to achieve is to improve the team productivity as much as we have already done for Java development for individual persons. And in doing that, we are following just a number of basic principles. So the first one is don't work against people. In every team, there is a set of established practices decided by the team how people work. So people write unit tests, or there's some other kind of tests. People write comments when checking in code to the version control system, and so on. But in the day-to-day work of a team, it sometimes happens that people break the practices. And it doesn't happen because people are evil or because they want to subvert development or anything, just because they are human. And the goal of our project is to make it as easy or as natural to follow the rules as to break them. So we don't just put barriers in front of people so that they simply can't do things the wrong way. We just guide them into doing things correctly. And another principle is dog food. So it's a known strength of our company that our products work best when we are using them ourselves. And the problems that our teams face are very similar to the problems of other development teams. So if the solutions work for us, then they must be also good for other people. And the development of Team Server was self-hosted, like almost from the very beginning. And as soon as the Team Server became capable of building and running tests, we moved the IntelliJ IDEA development to it. And recently, we moved another product of our company, the ReSharper. It also moved to the Team Server, and it's interesting because unlike IntelliJ IDEA, ReSharper is written in .NET. So we support .NET as well as Java. So this picture provides a bird's eye view on the overall structure of the project. So in the center, there is the main server, the central server, which manages all the work and all the stuff done by the builds, all the analysis procedures, and so on. So the Team Server has a web interface, naturally, which can be used to manage the server, to monitor, to configure things. And it also, of course, it integrates with the version control system where the sources of the product to be built are stored, and so on. And what's interesting is the agent part of things. So the Team Server does not do any actual builds or work by itself. Instead, it builds a queue of the things that need to be done, the builds or analysis requests or things like that. And it manages a pool of agents, which are separate computers, which have a specific software installed to do the work. And as an agent becomes available, it gets a new request of work to do from the server and performs the work and reports the results to the server. So this allows the system to be scalable as much as needed. So in the simplest case, the agent can run on the same computer as the server machine, so you can start with just one PC. And if you need to expand to scale more, then you simply add more agents and they do the work. And if you are really resource limited, which I guess Google is not, you can use developer machines as build agents, so they run builds when the developers are not working on them. And the last part is the IDE integration. So initially, we provide integration with IntelliJ IDEA, but later we are going to expand this to Eclipse and to other development environments. So now let's look again at what we actually do. So there is the distributed build environment with a central server, and the agents, and the server coordinates the work done on agents. And the server, this part of the product is IDE independent. So even if you don't use an IDE at all, you can still make use of the server through the web interface to review what's happening with the builds, to look at the results of the builds, and so on. So the server-side code analysis is also, it also can work either with an IDE or with a web browser. So the engine for the analysis is IntelliJ IDEA, but you can view the results in other environments as well. And finally, the collaboration support done which lives in the IDE, it allows you to simply exchange messages right within the IDE. You can also send links to the source code. You can exchange changes bypassing the version control system, and so on. So I'll talk in more detail about this later. So the first major part of the product is continuous integration support. Okay. So I guess most of you already know what continuous integration is. So just a brief look, and the article by Martin Fowler can give you more information in case you need. So the continuous integration is the process of running a build script, which is triggered either by timer or by version control check-in. The script gets the latest version of the code from the version control system. Then it builds the code, runs the test, and sends a report whether the tests have passed or failed. The benefits of that are simple. So you always know the current state of your project, whether it's red or green, broken or not. in case something breaks, you get to know about this immediately so that you can investigate the problem while you still remember the context, while you still remember why the change was made. And so it's easier to debug while you still have the things in your head. And you don't have the big productivity loss, which happens when someone checks in broken code to the version control system. Then all the other team members get this version of code. It doesn't compile, and people just sit around waiting for someone else to fix the code and not able to do any work by themselves. So the continuous integration can catch these situations much faster and get them fixed. So now let's have a brief look at the web interface of the team server. So you can see that there are the build server, the team server can build multiple projects, and for every project there are multiple build configurations. So for example, different test suites, or one for release build and another for tests. And this screen shows that one build of the build server project is currently running. What's interesting about this picture? So first of all, we keep a statistics on how long builds are running, and so we can show like a progress bar and the estimated completion time of the build. We also show the notification, the results of the build immediately as it runs. So the counter of the passed tests is updated as long as the build runs, and if some test fails, then it's immediately shown in the interface. And the artifacts link is this link is shown for the last successful build, and the artifacts are the specific files that have been built by the build process, like the installer of the product or something like that. And the server manages them as well, manages their storage and so on. So now let's see the details of a specific build. So this is like one build that was run at some time. So what's interesting here? This shows that the build server is capable of tracking the statistics of tests between builds. So it not only shows that one test has failed, it also shows that the test failed also previously, and the changes that broke the test must be not the changes in this build, but some older ones. So this shows the specific time when the test started to fail. And this screen shows simply the list of changes that went into a build, nothing really interesting here. So the developer name, the check-in comment, and the list of changed files. All quite simple. Now, what do we build? So of course, we build Java projects like IntelliJ IDEA itself. We build .NET projects, and by writing third-party plugins, the build server can be extended for building software with any other build platforms. So the Google's build system can be supported as well. So for Java, we didn't invent any of like build engines or anything like that. We support what everyone else supports. So so the build scripts themselves can be written with Ant or with Maven. And if you don't have a build script but simply have a project for your IDE, then you can use it as well. So you simply point to a project of IDEA or NetBeans or Eclipse, and the server picks it up and generates a build script from that. So for .NET, also nothing interesting, an Ant, MS Build, and Visual Studio Solutions. And the build server does not require any sophisticated configuration, so you simply unpack the archive, specify the version control server, CVS per4 source version, specify where exactly in the source control server the build script is located, and get the server running. And if one server doesn't handle the tasks very well, then you can simply install additional agents. So what's interesting about our builds? What specific problems with other tools do we solve? So the first problem is build administration. So anyone heard anything from our test machine? So in many cases, there are many kinds of builds that need to be run in a single environment. So maybe there are multiple projects or multiple source code branches for a single project, or different test suites, and so on. And of course, you can load them on a single machine, and it just it can run the build sequentially, but because there are so many different things to do, it all takes a long time to get the results of any individual build. And if you have multiple machines, then managing them becomes a problem because the traditional systems do not provide a unified interface for managing them. So some machines can drop out of the system and people will notice that. So our build grid or the distributed build environment provides a solution for that because there is a central interface for managing all the builds. So it allows to add more agents if required. The software of the agent is updated automatically, and so on. So the screenshot shows the administration interface for the agents. So the next problem is testing granularity. So with traditional systems, if the builds take a long time, which they usually do, the result is that check-ins are more frequent than builds. And if there are multiple changes in a single build, then it's unclear which of the changes broke the build. So with the team server, because there are multiple agents that can run the build in parallel, so every check-in can start a new instance of the build, and all the builds run on different machines in parallel. And the result of this is it becomes very easy to see which of the specific changes broke the build. So this one or that one or any other. So the next problem is that people do not always run tests. So it can happen for different reasons. Maybe there is a complicated environment setup needed for the test. Maybe the tests simply take a long time to run, or maybe you simply can't run all the test suite on your machine because the tests need to be run under different operating systems. And the end result of all this is simple, that people check in code without having run the test first. And the solution that we suggest for that is called remote run. So instead of needing to run the test on your machine, you can use the server to run the test for you. So you send your changes to the server. The server merges the changes with the version from the VCS, then does the usual test run, compiles and runs the tests, and sends to you the report. And while all the process is going on, you can work on something else or anything else, and your machine is not busy running the tests. And a further exacerbation of the problem is what's called 5 o'clock check-in. So you check in, you go home, and the build breaks. And your colleagues cannot work because the code is broken, and while you're dining with your family, you get a phone call calling why the things are broken, go fix them immediately. And you are displeased with that, naturally. So the problem, what we suggest as a solution. It's called delay check-in. The delay check-in is an extension of the remote run feature. So after the usual process of build and test, if the tests fail, it goes the usual way. You get the report, and you can fix the things like when you come to work next day. And if everything goes well, the changes are checked in automatically to the version control system. And because it's known that the code compiles and the test pass, then your colleagues can start using your code earlier than if you had checked in your code like next morning. So now let me show you a brief demo showing how it works in practice. So because a laptop is not really a good target environment for the build server, so I decided to record the demo on our real live production environment, our real build grid. So it's recorded, but it should be more interesting this way. So before you start using the team server IDE integration, you need to make sure that you are logged into the team server. So when you are logged in, the indicator in the status bar can be used to view the status of the build grid. So all the builds that are running, the status of each of them. So there are all the projects that are on our server the results of the last successful build for each of the projects, and you can also see the builds that are currently running. So for each of the build, even for those that are running, you can view the current build log, and you can view the tests that have already been executed. So now suppose that I have written a new unit test for my code, and I want to use the team server to run the test. So first of all, I need to ensure that, I need to select the change list where the change is located. So the change list feature allows me to separate different sets of my changes, so I can work with each one separately. So now I press the remote run button, ensure that the correct set of files will be sent to the server, write a command describing my changes, and select the build configuration that will be used to run the test. And these flags tell that my changes should be checked in automatically if the tests pass. So now I click the remote run button, and I get a notification showing that the remote run has indeed started. Now I can switch to the web interface of the team server and see now the changes have been moved to a different change list, which will be committed automatically if everything goes well. And I can switch to the web interface to see the build in progress. So here is the personal build icon. Here is the estimated completion time of the build, and these are the list of changes that went into the build. So you can see that my changes were merged with the latest changes by some other developer. Oops. So looks like I don't have the latest version of the demo here. So after this, unfortunately, sorry for that, I won't be able to show you the end result, but after the build is run, I will get a notification, and I will be able to view the list of tests, and I will be able to see that the test did indeed fail. So let's proceed to the next problem. The next problem is notification spam. So do you really expect me to read all the notifications? So the usual continuous integration environment generates a lot of verbose notifications for each build, and so you can see that a notification can take an entire megabyte. And of course, it's hard to extract the useful information from such notification, and as a result, people simply stop reading the notifications, and they learn about build failure not from them, but from a manager who comes in yelling at them why aren't you fixing the build? So we have a better way to notify about this. So first of all, there is a separation between status and notifications. So unlike some other environments, we always provide a clean information about the status of the build. So you have the indicator in your IDE showing that the current status. And you get notifications less frequently than with other environments. So you are notified only when a build fails, only when the build contains your changes, and if no one is currently responsible for fixing the build. The responsibility is the topic that I'll cover a bit later. Another advantage of our notifications is that they are sent earlier, as soon as a failing test has been detected. So you can start fixing the build while fixing one test as soon as you find out that it failed, while some other tests are still running on the build server. And the notifications are simpler. So instead of an email, you have an indicator, and you can also get notifications by Jabber. And if you need to get more details, then there is a very nice web interface that you can use to investigate the complete details for the build. Or you can use the IDE integration, which is even simpler to use. Wait, sorry. So now to the responsibility issue. So it's a common situation that a number of developers checked in some changes, and the build started to fail, and no one is working on fixing that, but because of course it's the other guy's fault. And everyone points fingers at each other and no fixing actually happens. So how do we solve that? We provide the interface provides a feature called take responsibility. So you can explicitly mark that I take responsibility for the build failure. I am currently investigating it. And it is shown to all other developers. And so they can, it's easy to see whether someone is working on the build or the build broke, but no one has looked at that and looked at it. And failure with no one responsible is, of course, a much more severe situation. And if you check in your changes and the build starts to pass, then, well, you are no longer responsible. The flag is cleared from you. So if the build starts to fail and if it's clear that it's you who needs to investigate, then you need to find out what exactly failed and why. And it can be difficult because the notifications are typically received in another application, which doesn't have any specific features for that. So you just get a long stack trace and just a long message, and someone in the message there is a stack trace, and there are no links to the source code, and even finding the stack trace can be a problem in a megabyte long message. So what we suggest instead is the IDE integration. So the IDE can show you the results of tests that were run on the build server exactly in the same way as if you have run them locally. So you have direct links to the source code of the fail location, and if you can figure out why the test failed by looking at the stack trace, then you can rerun the test locally under a debugger and get all the information that you need to investigate. So to summarize, what our continuous integration solution provides. So the distributed build environment allows you to get faster and more specific notifications for faster and more specific detection of incorrect changes. So the remote test run and delayed check-ins help you keep the version control system code clean. And if you do need to investigate the failure, you get a cleaner interface for that, and a cleaner interface that lets you find out about the failure. So the next part of the functionality is the server-side code analysis. So it's the analysis that we have in IntelliJ IDEA right now is one of the stronger points of the IDE. And probably the most highly used feature of IntelliJ IDEA is code inspections. Code inspections are static code analysis that are run in the background while you're editing a source code file. So you can immediately get notifications, for example, for method can be static or private method is not used and things like that. And the results are highlighted directly in the editor, and for many of the problems, we can offer quick fixes so that you can fix the problem with just one key press, Alt-Enter, and the problem is gone. But of course, that is not the limit of our code analysis features. We have much more than that. We have, for example, very powerful project-wide code analysis. So, for example, it can allow you to detect public methods that are not used anywhere. Or, for example, if some method has an argument that always receives the same value, we can detect that as well. And there are many different analyses. And moreover, even more than that, we support duplicate code search in entire project. So if there are two methods which have very similar fragments of code, we can detect that, and you can merge the methods into a single method. There is also code coverage support, and there are different other analysis tools from third parties that can be integrated with the build process. But all of this is great, but very few people use the advanced analysis features. And there is a very good reason for that, because the additional analysis requires you to break your workflows. So you need, instead of getting the results right as you are writing code, you need to have to specially think of, aha, I need to run the duplicates analysis. You need to allocate some time for that, because the analysis is quite time consuming. It will use much of your machine's resources and so on. And for many of the analysis, the report you will get is disconnected from the code. So you just get a bunch of HTML files somewhere, and you need to find out what's written in them and how it's related to the code you are editing. And many of those limitations can be avoided by using the server-side analysis. So first of all, the analysis is triggered automatically. So either by check-ins or by timer in the same way as builds are triggered. The analysis runs on the server and does not use any time of your development environment, and the results for the analysis are also collected on the server. And as you open some file for editing, the IDE requests the latest analysis results for that file and displays them right in the editor where you are editing the code. And even if the file was modified after the analysis was run, the results are adjusted so you still get useful information, and you can use that to fix the problems. So as a result, the features that you have right at your hands become much more powerful because they are augmented by the agent support. So finally, a little bit about our collaboration support. So there are many situations when, so of course, talking by words is a very efficient way to communicate. It's the way that I'm using right now, so it must be not too bad. But there are some situations when the communication involves code. And right now, such ways to communicate are not at their top efficiency. So for example, can you explain what the code is at full Java, the line 230 is about? And the other person is trying to scribble down, what file, what line, sorry, could you say that again, please? And it's just not very efficient. So there are like other utterances commonly heard in development rooms. And instead of that, we provide a collaboration solution integrated directly in the development environment. So of course, you can use simple messages, and even here you get an advantage because you do not have to grab the list of contacts that you need to talk to, because all the project participants are automatically added to the contact list. And because we are using a standard protocol, the Jabber protocol, you can use Google Talk to communicate with people. So you can use the IDE Talk to communicate to people who use Google Talk because it's the same protocol. And where this becomes interesting is the features which are integrated with the code. So you can send links to source code locations. You can send entire stack traces that are all clickable and navigatable. And another planned feature which is right now not implemented is what we call auto follow me navigation. So it's you can connect to some other person, which is like for code review. So your IDE will automatically show you the same code that the other person is looking at, and you can review the code together. And the next interesting feature is the possibility to exchange code fragments between different people. So you can see what I'm doing right now is I'm viewing the difference between some file at my computer and the same file on the computer of my colleague. So my colleague granted me the right to view the files that she's editing right now. And so I simply click a button to view the version that she currently has on her machine, which isn't even checked into the version control. And if I need to synchronize to that version, to test these changes on my machine, or to help her make some more changes, then I can synchronize to the version that she has right now. And again, I don't need to use the version control for that. I don't need to zip up the source code archive and email it to myself and something like that. So as you can see, the communication which involves code and not simply words, it becomes more efficient by the IDE integration features. So finally, some words about extensibility. So the core extensibility scenarios that we support are the following. So first of all, we can add other ways to notify about build failures. So the standard ways are email and Jabber, and you may want to add more, for example, notifications by SMS or by some special messenger that you have or anything like that. The next is more build runners. So this means integration with other. So this means two things. First, this covers support for other build platforms like Make or Sconce or whatever. So you write a runner that executes the build engine and gets the results from the build engine in a form that the server can handle, and sends the results to the server. And everything else is covered by the server. And the second part of that is additional kinds of code analysis. So for example, if you have developed a customized code metrics tool, then you can integrate it into the team server by writing a build runner that runs the tool and gets the results from the tool. And the third main extensibility point is support for additional version control systems. So I know that Google is using Perforce, so it's probably not interesting for you, but it can be useful for other people. So let's summarize. So the team server is a solution which can improve the team productivity. And it's not tied to any particular IDE. So even if you use not IntelliJ IDEA, but some other development environment or even Emacs, you can still get benefits from the team server installation. So the continuous integration that we provide solves many problems that are present with other continuous integration tools on the market. The server-side code analysis makes a great addition to the tools that are already available in many IDEs. It very much empowers the analysis features because you get the power of agent machines to run the analysis for you. And finally, the collaboration features help communication between team members when the communication involves much more than words, when it involves code as well. So the team server is currently in EAP, so you can download in the early access preview, so you can download a better version of the software to play with it yourself, or you can access our public installation of the team server, which currently runs builds for some open source projects. So you can see how it works without needing to install anything. So if you have any questions, I'll be happy to answer them. Sorry?
What's the price?
Not decided yet. Yeah.
Could you give me a ballpark or a range or order of magnitude?
No idea. Yeah. Okay, so the price of the team server is not currently decided. We are still the product is not released, so we still have the possibility to change our mind. Yeah.
A really integral part of our workflow here is code review.
Mm-hmm.
It seems like the only infrastructure for that in team server is topology mode. Or is there any more development?
Yes, for the current version, we don't provide any other specific support for code review.
Are there any plans for that, or version 2?
So the question is whether we have any support for code review other than the auto-follow-me navigation that was mentioned. And the answer is that we will consider adding such features in future versions of the product as we get to know the customer requirements better.
I really like the delay commit idea. I'm just wondering about one flaw. I thought of the idea before. Basically, what happens while the test is running with your changes? Someone else comes along and changes. And then have no choice but to integrate those specific things.
Sorry, I can't hear you very well because of all of.
So, yeah, the delay commit feature, I really like the idea.
Mm-hmm.
What I'm wondering is, what happens during the time the test is running? Anyone else can commit changes.
Right.
Do you allow that? And if so, how do you deal with the potential for conflicts between the changes that were committed and the changes that you were running the test on?
Well, basically, it's handled in the same way when you. So the question is how changes made by other people while the remote run build is running, how do we handle that? In fact, it's handled just in the same way as the conflicts which can happen when you check in code from the IDE. So you can also sometimes you check in code and you get notifications that someone else has changed the code and you need to merge. So in the case of delay check-in, if someone else has modified the code and there is a version control conflict, then you simply get a report notifying you that the check-in failed because of the conflict. And when you come to work later, you need to merge with the.
Even if the changes could be automatically merged, it doesn't ever do automatic
No, with automatic merge, the check-in goes through.
Even if that would break a test.
Yes, right now it's worked that. Right now it works that way. That way.
What's the difference between a delayed check-in and saving branches?
Well, mostly so the question is, what's the difference between delayed check-in and staged branches? So basically, it's a different way of solving the same problem. So indeed, it's possible to give an individual development branch for each of the developers, but we think that the delayed check-in solution is more flexible because it allows you to test different sets of changes in parallel, and you don't need to do any version control setup or something.
How do you solve the security issues during the delayed check-in? Who is checking in physically to the platform?
So the check-in itself is done by the developer machine. So the developer machine gets a signal from the build server that the check-in is allowed, and performs the check-in automatically. So yes.
Do these delayed commits act in an atomic manner? I mean, if two guys are committing something in parallel and it does pass the delayed test, will it be committed one after another and tested one after another? Or what are the...
Well, currently each of the builds is. So the question is whether the delayed check-in tests are atomic. Yeah. So if there are the tests done by each of the developers, so the changes done by each of the developers are checked in independently. So there is no check to ensure that they don't conflict other than the regular version control system checks. So there is no special provision for automatic or atomicity. So the question is, what is the largest project that we currently have running under the team server? So right now, because the project is in the EAP, we don't have any external deployments of the team that we know of. But the projects that we have inside our own company, they are pretty large. So IntelliJ IDEA is about 30,000 classes, and well, the number of developers won't impress you much, I think, but it's about 15 people, I think, working on the project. So any more questions? Right now, we are starting work on the Visual Studio integration, and it should become available in a few months. And Eclipse and NetBeans integration is planned for like half a year time frame, like that. So it will not be in the initial release, but in the release after the initial one. So I guess I'll pass the mic to Mike.
Hi, I'm Mike. I hope you're not tired yet, because we are going to talk about a really important thing. We are going to talk about pleasure. Unfortunately, not any kind of pleasure, but about a particular pleasure you can have when developing Ajax applications. Since Google is a web company, we think that this kind of pleasure is very relevant for you. When we are starting to talk about Ajax application and IntelliJ IDEA, we are being asked, why IntelliJ IDEA? Isn't it a Java IDE? Well, it actually started as a Java IDE. But soon we realized that developers don't do just Java. They do JavaScript, HTML, CSS, XML, and every possible technology there's around. And Ajax basically is just the set of the same technologies, like JavaScript, HTML, CSS, and probably some server-side code. So when you have IDEA in your hands and you've got to do some Ajax development, you've got Ajax with pleasure, since development with IDEA is always a pleasure. Well, what I'm basically going to do today is to make a short crash course of those little IDEA wonders we have for HTML, CSS, and JavaScript, so that you can start using them either today or just tell your friends to try it out. So let's start from HTML. Well, first of all, some basic stuff. For years, we have live templates which work for any language. These live templates do have expressions which can be filled in. There are different functions you can use for expressions which can be evaluated by themselves. You can have several expressions connected so that when you type in one place of code, another place of code is automatically modified, like in this sample of entering tag. Like you see div is automatically typed in the closed tag. Then we have, as always, as in Java, as in XML, we have a code completion. We know pretty much everything about HTML. That's why we can complete tags. We can complete their attributes, attribute values. We even know about file references from your HTML files. Like when you're doing an href, we know that href usually points to a file, or img tag points to an image. So we can give nice, pretty completion so that you are not lost in your site. You're typing right reference. You don't get a 4 or 5 error. Here it is. Then, since we know that much, we can spot your errors in the code too. We have error highlighting for almost everything you've got in your HTML. Our goal is not to be as good as tidy, but we can spot lots and lots of errors for you. We can spot wrong tags in wrong context, which is not allowed to put black tag inside the P. We can detect wrong file references so that you detect them before pushing your code to a server side. We even have a quick fixes for all these errors, like you can instantly create a file if you are sure that you need it, so that you can do top-down development, not bottom-up. And we are pretty sure that most part of their days, developers navigate around their code. They are looking for some specific place. They are finding what they have to do. And that's why we have put much efforts in making navigation around HTML as pleasant as possible. You can navigate to files from your references. You can navigate even to images and have them previewed right in IDE. You can navigate to anchors. You can navigate to pretty much everything. If you don't want to break your workflow by navigating to another place, you can quickly look up what's going on in that file or in that image you're referencing right here. Here's a quick lookup of anchor. You can even have lookups in your completion list, so that when you're inserting the reference to an image, you are not sure which image that should be. You just hit one shortcut, and you see it instantly what will be shown here. Of course, we have find usages, like in every IDEA place. Find usages for files. Here are samples from our live site, which is actually working on JetBrains.com, which has thousands of pages, and IDEA finds all the places instantly. Like hit Alt F7, you've got all the places your file, image, or anchor is going to use. After you have found all the places, you can easily refactor them. You can rename your files and have all places changed accordingly. You can move your files to different directories and have all references correctly. You can try to save delete a file. If the file is not safe to delete, since it's used somewhere else, IDEA will warn you that it has some usages. You probably don't want to delete it right now. If it doesn't have any usages, IDEA will silently delete it for you. Here is a sample of usages after file is renamed, just to make sure that we are not lying. Like we added underscore, and it was rename it everywhere. We are trying to delete a PDF file from our site. It doesn't matter what we are deleting as soon as we have references. The idea was that we have 4 usages. You can preview them or ignore them or just preview them to make sure why that happened. That was just a quick look at HTML design, HTML coding features. But HTML doesn't cause us so much trouble as other parts of web development are. I'm talking about CSS. CSS is quite a complex stuff. It looks like it's very simple, but when you're trying to dig into it, you find out that it has its own complicated things. Well, for those of you who don't like to remember everything and to keep all in your head, we also have a code completion. You can complete pretty much of everything. You can complete tags, you can complete HTML properties, you can complete even colors, as it was shown. You can complete even IDs as soon as you have used an ID in your CSS file. We can manage and complete it so that you don't type wrong IDs in your CSS if you are going to reuse them. Of course, all this stuff works in HTML. Sometimes we do have to type in styles right into HTML tags. And we do have to use CSS classes and IDs in your HTML code. That's why all this stuff is usually completed here. You can complete IDs, which can be stored either from HTML from the same file, or all your website can be scanned, and all IDs and classes will be gathered from your CSS files, and you've got nice, pretty code completion of every possible class or ID which can be applied to a place. Of course, we have our highlighting. We can't live without it. We highlight as well as warnings, like unused selector. We can spot that you are not using it anywhere. You can safely delete it. We also highlight syntax errors. We highlight wrong values. We highlight even when you're overriding one property with another one. We just show you that one property is redundant and another is not. Like, you should just make your mind what the margin should be, 12 or 15 pixels, like, so that you don't do many mistakes. And for many errors, we have like quick fixes. And besides quick fixes, we have like convenient ways to create large parts of your site from usages. Like, you just type ID, hit one key, and we'll generate selector for you automatically, so that you don't spare your time locating your CSS file, enter an ID, trying to remember what is it. Like, hit create selector from the place, and we've got it for you. Just type your site, don't spend your time on easily automatic things. When you have all the site done, probably by you or probably by somewhere else, it's quite important to see what's going to apply to this place. With this thing, you just select an ID, hit one key, and go to selector, which can be applied here, modify it, return back, see another one. You can quickly navigate between different selectors, all your CSS files. Here's a small sample. If you are not keen about switching your tabs and switching your workspaces, like, you can always look up the context of the rule, like, in place. Hit one key and see all rules which might be applied to particular HTML line, particular HTML tag. Here it is. It's really convenient. Our web developers, our web designers who are creating our site have nothing to do with Java, but they're still using IDEA just for this purpose. You can also find usages of all your classes, all your IDs across all your site. Like, hit Alt F7, and the same way you find usages in your Java code, you can find usages of your selectors, IDs, and pretty much everything. You see, we've just spotted an unused class in our own website. Like, no usages found. Also, you can quickly highlight usages in one of your file, quickly navigate through it, quickly look up. See, all this stuff we have working for Java is working for CSS. It's amazing that people don't notice it, but we have it, and it really helps you develop your web pages, either they're static or not. And the most useful feature is just to see all the rules which might be applied to a given tag, like which will be gathered throughout all CSS files in correct order. You'll got all the properties which will be applied to your tag, so that you can easily spot why your label is really red in your website. So which property has overridden this one. We are aware of all the rules of CSS cascading, CSS applying. Of course, we are not aware of your particular browser bug, but if we stick to standard, we can find out what applies here. And we've got refactorings. Of course, we can't live without refactorings. You can rename everything, class, ID, doesn't matter. Like one hit of the key, quick preview of usages, do refactor, and every usage is changed. Here it is, like you see it's changed everywhere. Well, now we are moving to our most wonderful stuff we think we have right now. We are moving to JavaScript. Well, JavaScript is a really complex thing. Nobody supports it in a good way beyond basic syntax highlighting. We've done lots of more. We've done lots of more for you to have your code written with real pleasure. First of all, we have code completion. But we don't have just keywords code completion. We complete pretty much of everything. Here you see just Dojo toolkit. You might be aware of it. Just drop it into my web application. And all the Dojo stuff is completable. Like you hit dot, hit control space, and you've got everything there might be after that dot. You don't have to remember all that things. You can spot it right from the place. And it's work for JavaScript without binding to any particular framework. I'm pretty sure if you drop your own JavaScript files, it should be working okay. Then we've got error highlighting, but not just syntax highlighting. We not just highlight you the wrong syntax constructions like missing brace, missing bracket, missing semicolon. We also highlight the usages of wrong symbols, like here is initialized function, which doesn't exist. We are highlighting implicitly declared variables, which are probably bugs. Maybe not, but they're probably bugs. We can highlight lots and lots of things in JavaScript, which we do try to understand your code, and we do try to highlight it as good as we highlight Java one. Of course, we have JavaScript formatter, like we can suit almost every coding style you might imagine. We have hundreds of options for brace placements, for spaces, for roping, just for anything. Like, it's been driven by the same Java coding styles you have in your project, so that your code will be looking the same as Java one. And we've got actual working find usages in JavaScript code. You can hit a function or a method or a property or a variable or parameter, hit Alt F7, and you've got all usages across all your site, across all your JavaScript files of the given function, so that you are not lost anymore in your JavaScript. You can even rename all the stuff which you don't like with the same automatic rename, which is safe, convenient, and fast. Here's a sample, like preview over name, just hit do refactor, and everywhere it will be renamed without any troubles. We also have small refactorings for JavaScript, like introduce variables. We don't have big ones, like object-oriented refactorings, like in extract class, and so on, but we have them coming in. We are actively thinking about them, and we are pretty sure we'll have them sooner than anyone. We've got the same highlight usages, which is really convenient when you are pretty sure that the usage is right in this file. You hit one shortcut, all usages are highlighted on the gutter, are highlighted in source code. You can quickly navigate between them, and You're the king of navigation. You are moving with a light speed in your source code. And very important thing, we have a go-to symbol which navigates you to any symbol in your project, in your JavaScript files in a matter of seconds. The same way you have got used to hit Ctrl-N and navigate to class, you now can navigate to anything in JavaScript. You can navigate to functions, classes, properties, everything that is global. We, of course, support camel humps. We support regular expressions. We support all that stuff which we support for Java. All this is possible in your JavaScript development. Here you see lots and lots of stuff in my project, but you can quickly find the one you need. And if you have already found a source code you are working in, you can easily navigate to the things you are using right in your code. Either it is just HTML or JS file, you just hit Ctrl-B, and you're at the place of definition of the given function to check it, to fix it, or to select anything else. Here is a sample of using jQuery. All across presentation, we are using quickly looked up in structure view. You can navigate to structure view, from structure view to your code, well, anything else. Well, actually, all the stuff I have shown you is already present in the shipped version of IntelliJ IDEA 5.1. You can already use it. You don't have to wait for any major release. But, of course, we have some stuff coming in the 6th version, which will be due in several months and which will be freely available at this July. First of all, we do know about DOM. We know about DOM. We know about various DOM properties. And even more, we know about browser-specific DOM. You see those Explorer icons, Firefox icon? You know that this thing is present only in Firefox, only Explorer. You don't have anymore to have those references on your desk and so on. Even more, we are doing some sort of type inference. We know that .node just was a selection. Right now, it will be an element, so that if you fetched an element by ID, now we'll show you only the things DOM node can have. Not all the stuff in JavaScript. We know that this is a DOM node, so we show you nice, precise lookup. We also are building knowledge of special functions and different conventions different libraries might have. For example, we have a plugin which supports $function prototype. It can be pretty much everything, so that with $, you know that this is $returns in DOM node. You know that $parameter is ID or class selector, so that all references, all the stuff is working. And even if you rename an ID in your HTML files, all getElement by ID will be renamed accordingly. What we've also done is so-called smart completion. You know that JavaScript is a highly dynamic language. A developer can make sure that pretty much everything might be called from everywhere, like from unexpected places. That's why we are showing huge lookups of everything possible after a dot. But in most cases, you've got a statically deducible methods, properties, and so on. That's why we've created a smart completion, which shows you only statically deducible ones. Here you see, after a dot, all the stuff which is present in your project, and that's why it can be called there. But after invoking a smart completion, we show smart, small completion list. We also have lots of additional JavaScript intentions coming. There are more than 70 of them. We have detections for common bug patterns. We have detections of probability concerns. You see document all probably used for platform detection. You shouldn't do document all in your JavaScript files if you are going to do cross-browser development. We even can spot like potential places for optimizations, unreachable code, code bugs. There are plenty of inspections, and amazingly, every JavaScript library you can download from internet, open an IDEA, and you see it all yellow. It has plenty of errors, unreachable codes, like even bugs. Every major library has bugs, and we have seen it with our tool. We've just shown some bugs to library developers at the Ajax conference, and they were amazed, like, wow, I've never thought, well, that kind of things can be found by IDE. We also have lots of JavaScript intentions coming, not just quick fixes for common problems or quick fixes for optimization patterns, but also lots and lots of code aids, which after you've been used to it, you can't live without them. You can flip if-else, you can change Boolean expressions, you can change or to end and vice versa, you can lots and lots of stuff like add var, a lot of things. After you've been used to it, they're just one keystroke away, and you are much more productive with all these things. Well, we've done lots of cool features for JavaScript, but I should tell you that we've got major problems with JavaScript, just because JavaScript language is a really dynamic one. We can't reliably detect all the usages that might be present, because JavaScript is basically has like maps and hashes going around. Everyone can modify them. So at first we thought that we can't do anything without it. But fortunately, most of JavaScript code is statically deducible. All the places which exploit JavaScript dynamism are compact, concise, and usually JavaScript developers don't do lots of things with dynamic features. That's why we thought that IDE should detect those patterns of dynamic usages, like dojo-lang extend is a feature which uses dynamic mechanism, but IDE can detect them and provide user with the best experience it can by analyzing those features. So actually, we have several ways of going. First of all, a user can choose a used pattern. Like, we can have several patterns built into IDE, and user, when he starts his own project, he just says that I'll be following like prototype conventions for class development, for object-oriented style. IDE will note it and will analyze all his code according to that. He also can use like annotation in his code to show that this one is really an extension of the class, or this variable is expected to be like a CSS rule and CSS selector, and so on. And we are also, in any case, we are going to implement an open API, which will allow everyone to hook into his own style of work with JavaScript, so that you have your own library which exploits dynamic features. You can write, I think, not that much code and tell IDE about your usage patterns. What we are also thinking about before JavaScript 2 is coming to the scene is typing JavaScript language. What we mean is not that you have to put some types in your code, but first of all, lots of things can be deducible by IDE itself. We already have basic stuff, and we have been working for a while for much more advanced type checking for JavaScript. But also, user can help us a lot by embedding some sorts of annotations, either JSDoc or any other standard that might arrive or we may create in collaboration with other developers or other IDE vendors, so that if you write those annotations in your code, we can read, detect it, and give you lots and lots of hints, have refactorings recognize them, have our completions and help features, those annotation enabled. So that's basically our call to collaboration. Like, we need to collaborate, like IDE vendors. I think there are no IDE vendors present here, but library authors, library users, everyone should collaborate together to create some sort of mechanism for JavaScript to make it more pleasant to work with. And everyone will use these features, and IDEA, and Eclipse, and probably any other JavaScript IDE that might come around. That's basically all about our JavaScript stuff. I have also several slides about our other features. They might not be of great interest for you since you're already IntelliJ IDEA developers, but we have a good XML support. We are not an XML studio like specialized for XML production, but we have one of the best support available for XML DTD and XML schema. We have error highlighting, we have code completion, so that if you have a DTD or schema, you can check that your XML is okay. We can guide you through your XML creation. We even can give you an XML completion for your XML files, even if you don't have a DTD or schema defined. We can analyze your XML file and guide you to create XML file with the same structure you have just written. We also have quite a few Java features, just to remember them. We have refactorings, validations, J2EE support, version control systems. We have Open API. We also have GSP support. I guess you don't do any GSP here. But still, everything I've presented here works in GSP files like HTML features, CSS, JavaScript, Java features, everything works in GSP. And we have lots of things coming in IDEA 6.0. It's GSF support, EGB3, like Visual HTML editor, which can allow you to preview your files, like quickly add them. We have code coverage and countless of other improvements. We also have some more features we are starting to talk about. First of all, we have for a while in development a Python plugin, which will be open source, I think, pretty soon. Don't know when, but you can expect it to come. I think you're already using it in-house. And we have started to work on Ruby on Rails in case you're just interested in, like, we should be, I think, interested in every web technologies going around. So we have started to work on it. And if you ever decide to rewrite Google in Ruby on Rails, it will be possible in some time. All these plugins will be open source. So if you want to participate or take a look or anything else, just drop me a line and we'll have all this stuff coming. Well, that's pretty all, I think. Do you have any questions? Thanks a lot.